Hi, everyone. Today we're diving into the physics of how we see the world, specifically why things sometimes look a little bent. We're talking about the refraction of light. You've definitely seen this before, like when a straw in a glass of water looks broken. Let's figure out why that happens.
So, simply put, refraction is the bending of light. This happens whenever light travels from one medium, like air, into another one, like water or glass. Because the light bends, our eyes get tricked, and objects can appear to be in completely different positions than they actually are.
But why does it bend? It's all about speed. Light has a top speed in a vacuum, but it slows down when it has to travel through gases, liquids, or solids. Think of it like a car hitting a patch of mud on one side. It slows down and turns. Interestingly, if light hits a surface straight on, along the normal, it slows down but doesn't bend. It has to come in at an angle.
Now, the speed of light in a vacuum is absolutely massive, 3 times 10 to the power of 8 meters per second. That's c. But the moment light enters anything else, like glass or water, it hits traffic and slows down. That change in speed is the key to everything we're discussing.
We measure how much light slows down using something called the index of refraction, denoted by n. It's a simple ratio, the speed of light in a vacuum divided by the speed of light in that specific substance. The bigger the n, the slower the light is moving in that material.
Okay, there are rules to this bending game. Rule number 1. When light goes from a material with a lower index, where it's fast, into a material with a higher index, where it's slow, like air to glass, the ray slams on the brakes and bends toward the normal line.
Rule number 2 is just the reverse. If light travels from a dense material like glass back out into the air, it speeds up. When it speeds up, it bends away from the normal line. So slow to fast means bending away.
To calculate exactly how much it bends, we use Snell's law. It looks a bit scary with the trigonometry, but it's just matching sides. The index of the first medium times the sine of the incoming angle equals the index of the second medium times the sine of the refracted angle. Let's apply this. Ever tried to catch a fish with your hands? You usually miss, right? That's because the light coming from the fish bends as it leaves the water. Your brain assumes light travels in a straight line, so you see the fish in a shallower spot than it actually is. Let's crunch some numbers. Say we have light going from air into crown glass at 30 degrees. We plug our knowns into Snell's law. Air is about 1, glass is 1.52. We do the algebra, take the inverse sine, and we get 19.2 degrees. Notice it's smaller than 30 degrees? That confirms it bent toward the normal.
One more, slightly trickier one. Light leaving a diamond and going into water. Here we're going from a high index of 2.42 to a lower one of 1.31. When we solve this one, our angle jumps from 25.5 degrees all the way to 52.7 degrees. It bent away from the normal because it sped up.
So to wrap up, refraction happens because light changes speed. We measure that speed change with the index of refraction, n. And if you ever need to predict exactly where a light ray will go, Snell's law is your best friend. Thanks for listening.